Welcome to Balaya Math Lectures. Learn every step. Today we will discuss the inverse of a square matrix by using Gauss Jordan method. We have a theorem that if A is a non-singular square matrix, then A inverse is equal to A inverse into A is equal to identity matrix. If A is a matrix of order n, then your identity matrix will have order n. This is the concept behind the finding of inverse of A by using Gauss Jordan method. If suppose A is a non-singular matrix, to find the inverse of this matrix, we will write A is equal to IA. If A is a non-singular square matrix of order n, then we have to write A is equal to IN A, where I is identity matrix of order n. Then you will reduce this matrix to identity matrix of order n by applying elementary row operations only. Now the same row operation should be applied on the prefactor of RHS. Then this will goes to some matrix B into A. Here your B is the required inverse of the non-singular matrix A. This is the procedure. Let us solve one problem to find the inverse of a given matrix. First of all, you have to observe the order of the given matrix. Here which is 3. So you have to write A is equal to I3A 1 1 3 1 3 minus 3 minus 2 minus 4 minus 4. This is the given matrix is equal to 1 0 0 0 1 0 0 0 1 into A. We have to apply elementary row operations only and make these two elements as 0, and then after use this element and make this one as 0. After applying the first two elementary operations, the element will be changed. Use that element what you have obtained here and use that element and make this one as 0. Use the same element and make this one as 0. And finally use this element and try to make these two elements as 0. This is the procedure to reduce this matrix into identity matrix. Finally you will get the diagonal matrix and you can make it identity matrix easily by applying elementary row operations only. So let us start the procedure. That means you have to use this element and make these two elements as 0. That means R2 tends to R2 minus R1, R3 tends to R3 plus 2R1, 1, 1, 3, 1 minus 1, 0, 3 minus 1, 2, minus 3 minus 3, minus 6, minus 2 plus 2, 0, 4 plus 2, minus 2, minus 4 plus 6, 2 again. The same row operations should be applied on the prefactor of RHS, so that no change in the first row. 1 0 0, R2 minus R1, R2 minus R1 minus 1, 1 minus 0, 0 minus 0, R3 plus 2R1, R3 plus 2R1, 2 0 1 into A. Now use this element and make this one as 0, which means R3 tends to R3 plus R2. Then this becomes 1 1 3 0 2 minus 6 0, add these two 0, add these two minus 4. The same row operation should be applied on the prefactor, which is 1 0 0 minus 1 1 0, R3 plus R2, 2 minus 1 1, 0 plus 1 1, 1 plus 0 1 into A. Now use this element and make this one as 0. That means R1 tends to 2R1 minus R2. 2R1 minus R2. So 2 minus 2, 0, 2 3 are 6 plus 6, 12. No change in the rest of the rows. 0, 2, minus 6, 0, 0, minus 4 is equal to the same row operation should be applied on the prefactor, which means 2R1 minus R2, 2 minus 1. 2 minus 2 minus 2 plus 1 3 0 minus 1 minus 1 0 minus 0 0. And no change in the rest of the rows. Minus 1, 1, 0, triple 1 into A. Now, use this element, make these two elements as 0. How? R1 tends to R1 plus 3R3 and R2 tends to 4R2 minus 6R3. R1 plus 3R3, R1 plus 3R3, 2, R1 plus 3R3, 0, 12 minus 12, 0. 4R2 minus 6R3, 4R2 minus 6R3, 0, 4R2, 8 minus 0, 8, 4, 4 6 are 24, minus 24, minus into minus plus 24, which will becomes 0. No change in the last row. That means 0, 0, minus 4. R1 plus 3R3, R1 plus 3R3, 6, minus 1 plus 3, 2, 0 plus 3R3, 3. Next, 4R2 minus 6R3, 4 minus 4 plus 6, 2, 4 minus 6, minus 2, 0 minus 6, minus 6. No change in the last row, which is 1, 1, 1 into A. R1 tends to R1 by 2, R2 tends to R2 by 8, R3 tends to R3 by minus 4. Then this becomes 1, 0, 0, 0, 1, 0, 0, 0, 1 is equal to R1 by 2, 3, 1, 3 by 2, R2 by 8, 1 by 4, minus 1 by 4, minus 3 by 4, R3 by minus 4, minus 1 by 4, minus 1 by 4 and minus 1 by 4 into A. So let us take out the constant 1 by 4, then this will becomes I3 is equal to 1 by 4 into, if you take out 1 by 4 outside, then you have to multiply this row with 4. That means 4 3s are 12, 4 1s are 4, 3 2s are 6. If you multiply with 4, 2 will cancel out 2 times. 2 3s are 6. And 1 by 4 is taken out. So 1, minus 1, minus 3. And here also minus 1, minus 1, minus 1 into A. This is just like BA is equal to I. Your B is required inverse of the given matrix. This is the way how to find inverse of a square matrix by using Gauss Jordan method or elementary row operations. Use Gauss Jordan method to find the inverse of the matrix A is equal to minus 2, 1, 3, 0, minus 1, 1, 1, 2, 0. This is the matrix. Now let us find the inverse of this matrix. So coming to the solution, write A is equal to I3A, because given matrix A is of order 3, which is non-singular also. So that 1, minus 2, 1, 3, 0, minus 1, 1, 1, 2, 0. This is the given matrix. And write the identity matrix here into A. For the sake of convenience, I am interchanging R1 and R3 for easy calculations. So R1 if and only if R3. Then this becomes 1, 2, 0, 0, minus 1, 1, minus 2, 1, 3. The same row operation should be applied on the prefactor of the RHS, which means 0, 0, 1, 0, 1, 0, 1, 0, 0 into A. Now use this element and make this one as 0. If it is non-zero, you have to make this one also 0. But it is enough to make this one as 0. That means R3 tends to R3 plus 2R1. 1, 2, 0. 0 minus 1, 1. Minus 2 plus 2, 0. 1 plus 4, 5. 3 plus 0, 3 is equal to, the same row operation should be applied on the prefactor of RHS, which is 0, 0, 1, 0, 1, 0, R3 plus 2R1, R3 plus 2R1, 1, R3 plus 2R1, 0, R3 plus 2R1, 2. into A. Now use this element and make this one as 0. How? R3 tends to R3 plus 5R2. Then this will becomes 1, 2, 0, 0 minus 1, 1, 0, 0, R3 3 plus 5, 8 is equal to the same law of operation should be applied on the prefactor of RHS, which means 0, 0, 1, 0, 1, 0, R3 plus 5R2, R3 plus 5R2, 1, R3 plus 5R2, 5, 2 plus 0, 2 into A. Now, use this element and make this one as 0. How? R1 tends to R1 plus 2R2. R1 plus 2R2. Then, this element will become 0. So, multiplying with 2, R1 plus 2R2, 1 plus 0, 1, R1 plus 2R2, 0, R1 plus 2R2, 2. No change in the rest of the rows. So 0, minus 1, 1, 0, 0, 8. 0, R1 plus 2R2, 2, R1 plus 2R2, 1. And no change in the rest of the rows. 0, 1, 0, 1, 5, 2 into A. Now use this element and make these two elements as 0. That means R1 tends to 4R1 minus R3. Multiply this one with 4. 8. 8 minus 8 will become 0, which will be 0. This is also 0. This is 4 only. And also use this one and make this one as 0. R2 tends to 8R2 minus R3. Then this becomes 4R1 minus R3, 4, 0, 8 minus 8, 0, and 8R2 minus R3, 8R2 minus R3, minus 8, 8 minus 8, 0, 0, 0, 8 is equal to 4R1 minus R3, 4R1 minus R3, minus 1, 4R1, 8 minus R3, 8 minus 5, 3, 4R1 minus R3, 4 minus 2, 2, 8R2 minus R3, 8R2 minus R3, minus 1, 8 minus 5, 3, 0 minus 2, minus 2, 1, 5, 2, no change in the last row, into A. Now, make these elements as 1. That means R1 tends to R1 by 4, R2 tends to R2 by minus 8, R3 tends to R3 by 8. 1, 0, 0, 0, 1, 0, 0, 0, 1 is equal to 1 by 8 into, if I write 1 by 8 outside of this matrix, you have to multiply this row with 2. So, minus 2, 6, 4. And R2 by minus 8, already minus 1 by 8 is outside. 1 by 8 is outside, you have to multiply this row with minus. That means 1, minus 3, 2. And finally, you can write simply as it is. 1, 5, 2 into A. You can notice that BA is equal to I. So your B is the required inverse. Therefore, B is equal to A inverse. Which means this can be denoted as BA, where B is your required inverse. So B is equal to A inverse is equal to 1 by 8 into minus 2, 6, 4, 1 minus 3, 2, 1, 5, 2. This is the way to find the inverse of a matrix by using Gauss Jordan method. These are the homework problems for finding of inverse of a matrix by using Gauss Jordan method. This is the first problem. Find the inverse of the matrix A is equal to, this is the matrix, using elementary operations. It is enough to use the Gauss Jordan method to find the inverse of this matrix instead of using elementary operations. Here, using Gauss Jordan method, find the inverse of A is equal to, this is the matrix. I request all of you, please like, share, comment and subscribe my channel Balaya Math Lectures. Thank you.